In this video, we're going to talk about how to solve a rational equation. So in solving rational equations, it's of course important to know what a rational equation is, because the strategies we'll use to solve different equations will be different. So a rational equation occurs when we have a fraction, because rational, of course, includes the word ratio, which just means fraction, and typically you're going to have a fraction that has a variable in the denominator. Now there's different methods to solve, and before we solve, I want to talk to you about something that's really important, which is the restriction on the domain. When we have a rational equation, we know that we don't want some number over 0 because that's undefined. And so we don't want to have anything that's undefined. So what we want to do is we want to look at the denominators and make sure that they don't equal 0. So I'm going to say y plus 5 can't equal 0. And then I'm going to solve for that. When I subtract 5 from each side, I say that y can't be negative 5, so that's a restriction, is that y can't be negative 5. And I'm going to take 3y minus 2 and say that that can't equal 0. So I'm going to add 2 to each side to get 3y equals, or does not equal 2. Divide by 3 on each side to get y does not equal 2/3. So my restrictions are that y cannot be negative 5 and cannot be 2/3. So what does that mean? That means I'm going to do all of this work and I'm going to solve. And when I find my solutions, if one of them is negative 5 or one of them is 2/3, I'm not going to include that as a solution. So let's go ahead and do the work. In this case, I'm going to give you several strategies. So in this case, I have two rational equations and I don't have any other plus 3 or minus 2 or anything like that. I just have 2. So the easiest way to solve this is to cross multiply. So I'm going to take 3 times 3y minus 2, and I'm going to take 3 times y plus 5, and I'm going to set those equal to one another, and then I'm going to solve. So we know how to solve. We've done a lot of practice so far. We get 9y minus 6 equals 3y plus 15. Then I'm going to get all of the y's to one side. I'm going to choose to subtract 3. And notice I'm going to start not showing this step because I don't need you to show that step. As long as you're doing one step at a time, I can follow what you're doing. So I'm going to subtract 3y from each side to give me 6y minus 6 equals 15. I'm going to add 6 to each side, so I get 6y, and when I add 6 over here, I get 21. I'm going to divide each side by 6, so I get y equals 21 over 6. And of course, I don't want to keep it like that, so I'm going to divide both of those by 3, and that gives me 7/2, or 3.5. Again, I can do a check to make sure that this works out. So I'm going to put 3 over 3.5 plus 5 and say, does that equal the same thing as 3 over 3 times 3.5 minus 2? So now let's just work it out and see if that works. On the left side, I have 3.5 plus 5, which is 8.5. On the right side, 3 times 3.5 is 10.5. 10.5 minus 2 is 8.5. Because they both work, I've checked it and I know that they're correct. Now, when I'm done, this is my solution, I always look back here and say, is my solution okay? Yes, it is, because 3.5 is not negative 5 or 2/3. So I have one solution, and that solution is 3.5. Now, this is also a rational equation, and it's a little bit different than the last one, because on the last one, all I had to do was cross multiply. On this one, I'm going to do it like the strategy that I used when I was clearing fractions, same thing. But before we get to that, let's look at the domain restriction. I need to make sure that my denominator does not equal 0. So the first thing I'm going to do is look at y minus 1 and say y minus 1 does not equal 0. And that means that y does not equal 1. And then I'm going to skip over that more difficult one for just a second. And I'm going to look at y plus 3 and make sure that does not equal 0. And then I'm going to subtract 3 from each side. Forget, I'm not showing that anymore. And I get y cannot equal negative 3. So you might be wondering then about y squared plus 2y minus 3. Well, when I get something like that, I always want to factor it. Now, we haven't refreshed ourselves on factoring in this class yet, but in this week's video, there is a solve by factoring. You're going to want to watch that video. So I'm going to go through it with you quickly here, but for a more in-depth look at factoring, make sure you're looking at that Solving Quadratics by Factoring video. Again, here I'm going to look at, I want to put this into two binomials. So I'm looking at y squared plus 2y minus 3. I'm saying, are there numbers that multiply to 3 that have a difference of 2? And of course, I want them to multiply to negative 3. So 3 and 1 have a difference, or multiply to 3 and have a difference of 2. And I want it to be positive 2. So it's going to be a positive 3 and a negative 1 in order to multiply to negative 3. So what does that mean? That means this is y plus 3, y minus 1. If I FOILed that back out, I would end up back here. And what does that help me with? Well, that means I can rewrite this as y minus 1, y plus 3. And if I take a look, I've already checked both y minus 1 here, and I've checked y plus 3 here. So I don't need it to check the restrictions on the domain anymore. Now we're going to go into solving. Now again, to solve, I'm looking for the least common denominator, which is more difficult now because I've got y's in here instead of just numbers. But if I'm looking at the three denominators, I have y minus 1, and I have y minus 1, that was horrible, let me try again, y minus 1, y plus 3, and then I have y plus 3. So if I'm looking at those three, what's the common denominator? Well, if I took this times y plus 3, well then it looks the same as the middle. And if I took this times y minus 1, then it looks the same as the middle. So this is my least common denominator. And so what I'm going to end up doing is I'm actually going to take all three fractions by the least common denominator. Here's how this is going to look. I've got 1 times y minus 1, and you'll get to the point where you don't have to show quite all of the work, but I'm going to just show everything so there's no confusion, or minimal confusion. And then I've got y plus 1 times y minus 1, y plus 3, still over the same denominator I had before. So notice I'm not messing with the denominators at all. And then here I have 1 times y minus 1, y plus 3, over y plus 3. So why did I do all of that? Because I love to cross things out. So I've got y minus 1 that I can cross out. I have y minus 1, y plus 3, and I have y plus 3. What does that leave me with? It leaves me with 1 times y plus 3, which is just y plus 3. So that was the 1 and y plus 3. It leaves me with y plus 1. And notice I'm not writing these in parentheses because I don't need to in this case. And on the right side I have 1 times y minus 1, so that's y minus 1. So this is way easier to solve now. So let's go ahead and combine like terms. I get 2y plus 4 equals y minus 1. Subtract y from each side. Y plus 4 equals negative 1. I subtract 4 from each side to get y equals negative 5. And then I check it over here against my restriction, and I see that y minus 5 is a-okay, so that is my one solution. One more for me to try with you. I'm going to take a look at this question with you. Start with the domain restriction. Our only domain is our only denominator is a minus 6, so say that cannot equal 0. Add 6 to each side, a cannot equal 6. So hopefully that's not our answer when we're all done. I'm going to do it just like the last one with the least common denominator. This one's easy. I only have one denominator, so it has to be a minus 6. And so I'm going to take everything times a minus 6. So my first fraction, I just included the a minus 6. Don't forget the 5 also has to be taken by a minus 6. A lot of people forget that. And then I have 2 times a minus 5 times a minus 6 over a minus 6. Now I get to cross things out, which is super fun, and see what I have left. So on my first one, I just have a 2 left over. On my second one, I have a minus 5 times a minus 6. So I'm going to go ahead and distribute. Minus 5 times a is minus 5a. And minus 5 times minus 6 is plus 30. And then on the right side, those a minus 6 canceled, so I have 2 times the quantity of a minus 5. So again, I'm going to go ahead and distribute 2a minus 10. So now let's combine like terms. On the left side, I have minus 5a and plus 32. On the right side, I haven't done anything yet. Now let's get all the a's to the left, so I'm actually going to subtract 2a from each side. That gives me minus 7a plus 32 equals negative 10. I'm going to subtract 32 or add a negative 32 to each side. So I keep my negative 7a on the left. On the right, I get negative 42. When I divide each side by negative 7, I get a equals 6. So that would be my answer, except if I look over here, I can see that a cannot be negative 6. Because otherwise my denominator is 0. So what is my final answer here? My final answer is no solution, or the empty set. So always important to check the domain restriction. One final one for you to try on your own, so I do encourage you to press pause and try the question first before I go over it with you. Again, the first thing I'm going to do is look at the domain restriction. I know that 3x cannot equal 0, which means x cannot equal 0. I don't have to worry about the 6 because the 6 doesn't have a variable. And if I look at the x, obviously I could say x cannot equal 0, which I already knew that. So now I'm just looking at x cannot be 0. So if I get an answer of 0, that's not a good answer. Now I'm going to look for my least common denominator. So I'm going to look at the 3x, the 6, and the x. What's the smallest thing all of those can go into? Looks to be 6x. So I'm going to take 1 times 6x over 3x. I'm going to take 5 times 6x over 6. And I'm going to take 2 times 6x over x. Now again, why does that help me? Because now I can do some crossing off. The x can go away, and the 6 and the 3 can reduce to 1 and 2. So what's left over? Just 2 for my first fraction. For my next one, the 6's go away. I'm left with 5x. And for the last one, the x's go away. I'm left with 12. That 12 was a little shaky. Let's try that again. Now I'm just going to solve. This one's pretty simple. Subtract 2 from each side. I get 5x equals 10. Divide by 5 on each side. I get x equals 2. I double check it against my restriction. 2 is just fine, so my answer is 2.